Okay, let's get right to this recording. This is a long video, so let me get started. Today we're going to be talking about simplifying variable expressions. A lot of definitions I need to go over in the beginning here. So I'm going to go through. I'm not going to make you write down the definitions, but make sure you mark each part and maybe add in your own parts that I added in there that I just talk, and you might want to add in your own information to help you. First thing I want to talk about is terms. And terms are the different parts that make up an expression. And in this example we have three terms. And terms are separated by addition or subtraction, so that every time you see a plus or a minus sign, that's going to separate our terms. So in this example we have the three terms. The 5x, the 4x, and the 7 are our terms. Staying with terms, I want to talk about like terms. Now the 4x and the 5x are like terms because they're identical variables. So that's like terms. And identical variables have like terms. Now numbers just by themselves, like if I had the 7 and I had a 9 plus 9, those would be like terms because they're identical variables. They both don't have any. And it has to be identical. So an x and an x squared, they would not be like terms because they're different. One is an x, one is an x squared. Now working with our terms with variables, we have a word that we use to refer to the number that's in front of the variable. And the formal definition is it's being multiplied to our variable, and that is a coefficient. So this, I changed my pen, let me change that back. A coefficient is the number that is being multiplied to a variable. Coefficient. Okay, and that is the number that is being multiplied to the variable. So we need to make sure that we are multiplying that, not adding or subtracting. It needs to be multiplying. It's the number that's in front of the variable, and it doesn't matter what the variable is, and the coefficient is just the number. The last definition is if we have just a number, it's called a constant. Okay, and a constant is a number that's by itself with no variables or anything. It's just a number. It's constant because it is always that amount. So for example, 7 is a constant because it's always 7. It never changes. All right, those are our beginning definitions. Make sure you are familiar with these words. I'm going to move on to my next slide. In our next slide, we're talking about identifying the parts of expression. So there's my words, terms, like terms, coefficient, and constants. And we're going to see if we can identify them in an expression. So I've given you an expression. First thing I want to talk about is we're going to be using the commutative and the associative property a lot. And if you remember, we discussed that those only work for addition and multiplication. Well, I'm not worried about multiplication right now. I'm just worried about addition. So since I have subtraction in here, what I'm going to want to do is I'm going to want to turn those all to addition problems. So plus -4, plus -5c, and plus -6. You want to make sure that they are addition signs first, because when you start identifying the terms, you want to make sure that you're writing them down in the correct positive or negative form. And if you keep them as minus, some of you can realize, okay, a -4 means it's a -4, and that's great. But if you're struggling or you're beginning, it's better to turn them to plus negatives so that you remember that that is a -4. So for my terms, I'm just going to list them here. 13c is one term, separated by plus -4. Then -5c, and my fourth term is -6. So I have 4 terms. I just list them in my terms. My like terms, remember, are ones that are identical. So I have a 13c and a -5c. So that's going to be 13c and -5c. You also might remember I said that constants, numbers, are also like terms because they're just numbers. Constants are like terms. So -4 and -6 would be a second set. Sometimes you have an expression with no like terms, sometimes you have one, sometimes you have more than one. In this case we have 2 sets of like terms. Coefficients, remember, the numbers that are being multiplied to the variable. So that's a 13 that's being multiplied to the variable and a -5. And this is the key about making that a plus negative, is every time I'm writing down that -5 or -5c, it's negative, not just a 5c. Subtracting something is the same as adding a negative, and so that you have to know that the number is negative. Our constants are just our numbers without any variables, so that's -4 and -6. And that is how you list your identifying parts of an expression. So you just have to be able to identify them. Now we're going to use these in our next examples. So I'm going to go to my next slide if you need to pause. In our next example, we're actually going to start simplifying them, and you have to know your terms, you have to know your like terms. First thing I'm going to do in example A is I'm going to turn my minus into plus and negatives. Okay, and actually in B I'm not going to do that and show you how to do it when you don't do that. But here I have all addition, so now I can use my commutative property because it's all addition, so I can rearrange them however I want. I am not going to make you rewrite them, however you are using the commutative and associative properties to do this work. First thing I'm going to do is I always want you guys to start with the variable. You don't have to start with the variable, it's fine either way, but this way we're consistent, so when we're grading we can see some answers that are similar, and you can start to figure out which is right. And then not that starting with the constant's wrong, but if we all do that it'll be a little easier to go over. So I'm going to start with my variables. So I have a 12k here plus negative 7k there. So I'm just going to do that work. They're different signs, so I subtract them. I have more positives and negatives, so it's 5k. Nothing happens to the k. It stays there. It's just the coefficients that I'm adding and subtracting. The k's are still there. The next thing I have is I have a negative 9 plus 20. Again, they're different signs, so I subtract them, and that's 11. Since 20 is bigger than 9 and it's positive 11. So my final answer is 5k plus 11. In example B, I'm going to show you how to do this without making them plus and negatives, although you're more than welcome to. The one thing I want to bring up in B is the identity property. Now remember, anything times 1 is itself, which means the reverse is true. If I have a variable by itself, that also means it's 1 times that variable. So I'm actually going to put a 1 in front of the w to remind me that I have 1w there, so that when I'm doing my adding and subtracting, I know what number I'm using. Now I'm going to start with my variables again first. So I have a positive 8w. Notice it goes operation term. Okay, not term operation, but operation term. And I have a minus 1w. So I have 8w minus 1w, which means I have 7w's left. When I look at my constants, I have a 5 minus a 6, and 5 minus 6 is negative 1. 7w minus 1. And that's my final answer. If you were to write 7w plus negative 1, that is the same thing, and that's okay. Alright, so that's okay to write it that way. I would not mark that wrong. Okay, if you need to pause it, go ahead. I'm going to move on to my next slide. In our next example, we're going to do the same thing, except I'm adding the distributive property. So you have to identify the distributive property. And in example A, that's this 5 times the quantity of 6 plus b. That's our distributive property. Anytime the distributive property is involved, you must do that first. So I'm going to do 5 times 6 and 5 times b. 5 times 6 is 30, plus 5 times b is 5b. I have to write the rest of the problem. Yes, you must write the rest of the problem, so rewrite the whole problem. Now I don't care about anything that was originally written. I only care about what I have in blue there. Now I can combine like terms. 5b plus 4b is 9b. 30 minus 9 is positive 21, so 9b plus 21. And that's my final answer. Now looking at B, I have a new issue. Here's my distributive property, but I have a minus 3 in front, and that's very important. And again, I'm going to do a plus negative 3, and that's extremely important because you need to distribute a negative 3 to each number, not a minus and then positive 3. You will not get the correct answer. Again, we're working with everything being a positive or a plus, so you need to change that all, or at least in your mind, change it. And in this one, I suggest you actually change it on your paper. Then I distribute a negative 3 to each number. So I'm going to rewrite it as 4m plus 12 plus negative 3 times 2m is negative 6m plus negative 3 times 2 is negative 6. What happens is the second number is what ends up to be wrong if you don't do that. Now I'm going to combine like terms. 4m plus negative 6m is negative 2m. Then I have a 12 plus negative 6. They're different signs, so I'm going to subtract them. That's 6. 12 is bigger and it's positive, so it's a positive 6. So I get negative 2m plus 6. So that's how you simplify expressions with parentheses. I'm going to go on to my next slide, so if you need to pause, go ahead. In my last example, which I'm actually going to take 2 slides for, I'm going to write, and we really need to practice our writing on these. Now in this problem, we're working out for 45 minutes, we're jogging and swimming, we're doing 14 calories for jogging, 8 calories per minute when swimming. I want you to write an expression and simplify it when J is to represent the time you jog, and you can read that yourself. So we're always going to be working in J. So if I want to know how many calories I burn in my workout, even though I don't know how much I swam or jog, I can figure out an expression to find that answer. So first thing I want to know is, the easy one is to figure out how many calories I burn when I jog. Well, I'm going to do 14 times J. Okay, J is the amount of time I jog. Okay, so 14 times 10 minutes, it's 140 calories jogging. That one's pretty easy. The next one is the swimming. Now I can't just do plus 8S because I have to have it in terms of J. So instead of writing S, I have to think about how long did I swim. Well, when I think about how long I swam for a total, or I worked out for a total of 45 minutes. So that's going to be 45 minus the amount of time that I jogged. Whatever time is left over, that's how long I swam. So that's what I'm going to put in for swimming. So the J is for jogging, and then in parentheses, the 45 minus J, that's going to represent how long I swam. Now I can do the distributive property and combine terms to simplify this expression. I'm going to get 14J plus 8 times 45 is 360, minus 8 times J is 8J. Combining like terms, 14J minus 8J is 6J, plus 360. There's my expression simplified. Now I'm going to go to the next screen and put it and apply this expression. So if you need to pause, go ahead and pause. Now if you remember, I had 6J plus 360. I'm going to rewrite it. You don't need to rewrite it. You already have it in your notes. So I'm going to have 6J plus 360. Now I want to know if I jog for 20 minutes. So all I'm going to do is plug 20 in for J, because J represents the number of minutes I jogged. So I'm going to do 6 times 20 plus 360. Now you guys need to write that, but then you can use your calculator. That's 120 plus 360, which is 480. Now this is a word problem. 480 what? I burned 480 calories, and that would be my label. And that is how you write an expression and then apply it to a problem once you figure out how long you've jogged. That concludes our lesson today. So if you make sure you rewind and go back and watch anything that you didn't understand. This is very important stuff that we're going to be using a lot in the next couple of chapters. So make sure that you're going back and reviewing. Make sure you know the definitions. And if you ever need to watch this video, watch it again and rewind the parts so that you guys understand it. Have a nice night, and we'll see you tomorrow.